This is question 2 from the vector problems that have sine and cosine law solutions from the review for relative motion. So a pilot wishes to reach a city 600 kilometers away in the direction 15 degrees south of west in 2 hours. If there is a wind that is of 70 kilometers per hour blowing at 10 degrees west of south, what must be the heading and airspeed of the plane? So I've drawn a diagram that goes from A to B, right? And it's in a direction 15 degrees south of west, which I've labeled here. So we want to find the heading and the airspeed of the plane. So since we know that we want to get from A to B, we want to go in a direction 15 degrees south of west, that must mean that this is the resultant. This is what someone on the ground would see. This is where they would actually end up going. So that must mean that the pilot has to correct for the wind speed. So we want to find what the direction and the speed that the plane would go in if there was no wind. That is the heading and airspeed. So that must mean that our heading and airspeed, our airspeed vector, has to add to the wind to find our resultant in blue here. So the wind is blowing at 10 degrees west of south, so that's going to look like this. 10 degrees west of south, and then our airspeed, so our original speed, is going to be from here to here. So you can see that this is our airspeed, and it adds to the wind speed and gives us our resultant. Okay, so I've relabeled the diagram to make it a little bit neater. This is our wind speed, this 70 kilometers per hour here. I've just labeled the 80 degrees south of west instead of 10 degrees west of south, just to make it a little bit neater. Okay, so let's take a look at what we know and what we need to know. So they tell us that the wind speed is 70 kilometers per hour, but we actually also know the resultant speed. And that is because we know the distance that we have to travel and how fast we need to get there. So that is our resultant because that is how fast that we actually want to go. So our velocity is going to be distance divided by time, which is going to be 600 kilometers divided by 2 hours. That is going to give us 300 kilometers per hour. This is our resultant speed because this is how fast we want to go. Okay, so let's label that 300 kilometers per hour here. Okay, so now we have to look for some angles. And in order to find angles, we need parallel lines. So what I see first is this set of parallel lines. So if you take a look at this east-west line and this east-west line, they're parallel, and this, our wind vector, is kind of like a diagonal. And we know that our alternate interior angles, which would be this 80 degrees here, and this big angle, so from the east-west line all the way up to that vector, they are the same. So we know that this big vector is 80 degrees. Now, let's look at another pair of parallel lines. Let's look at this east-west line and this, this east-west line. Okay, so these two are parallel. Now, if we take a look at this diagonal, right, we know this angle here. The alternate interior is going to be this angle here. So they're going to be the same. So we know that this angle is 15 degrees. So if we want, this angle, then we can take 80 degrees, which is this bigger one, minus 15 degrees, which is this smaller one. And 80 minus 15, that would give us 65 degrees. And that is our angle, our angle that we want in the triangle. So this is 65 degrees in the triangle here. Okay, so now that we found this angle, 65 degrees, we can find our airspeed, which is going to be this purple line here. Okay, so I've labeled the angles. So I call this one angle A, I'll call this one angle B, and I'll call this one angle C. Okay, so I'll label the sides as well. So I'll call this one side C since it's opposite to angle C. And I'll call this one side A since it's opposite angle A. And our last one, which is what we're looking for, is side B. And we don't know that yet. Okay, so if we take a look at what we know, we have this side length. We have this side length. And we have an angle that is in between them. And since this angle happens to be the angle that is opposite to side B, which is what we're looking for, we can use the cosine law. So let's set up the cosine law. And the letters that are used in the regular format of the cosine law, that doesn't really matter as long as you have two sides and an angle in between. So now my cosine law is going to look like b squared equals a squared plus c squared minus 2ac cosine b, where this is the angle opposite to the side that we're looking for. So the letter names don't really matter as long as you have two sides and an angle between them. Okay, so let's solve for b. B is going to equal the square root of all of this. So a is 70 squared plus 300 squared, which is going to be our c squared, minus 2 times a times c times cosine b, which is the angle across from the side that we don't know. So across from the angle that we don't know, 65 degrees. And if you plug this entire expression into your calculator, that should give you 278 kilometers per hour if we're rounding to 3 sig figs. Okay, so now we know that B is 278 kilometers per hour. And now we just need to look for the heading. So to look for the heading, we need an angle. So you can look for this angle or you can look for this angle. I am going to stick to this top angle here that I've labeled in blue. Okay, so to do that, we can find angle A, and then we can subtract angle A from 15. So we do 15 minus angle A, that will give us our heading. So let's do that. To find angle A, we can use the sine law. Since we have the side A that's across from it, we have another angle, and we have the side that is across from that angle. So let's set it up. We will have sine A over A, which is the side that's opposite to it, equals sine B over B, which is the side opposite to that. So sine A, we don't know what angle A is, but we do know the side that is opposite to it right here. A equals 70 kilometers per hour, so sine A divided by 70 equals sine B, which is the angle that we have here, 65 degrees. Sine 65 divided by side B, which is across from it, and we just solved for side B, right? That's 278. All right, so let's isolate sine A. So sine A equals 70 times sine 65 divided by 278. So I've just multiplied the 70 over, and that will give us 0.228 dot dot dot. I'm not going to round here since we still need to find angle A. And to find angle A, we need to take the inverse sine of this decimal. So inverse sine of 0.228 dot dot dot. And that will give us 13.19 something degrees. Now be careful, angle A is not our final answer, but instead we need the heading, which again is going to be 15 degrees minus A. So our heading will be, our heading is equal to 15 degrees minus A, which is 13.19 something degrees, which will give us 1.81 degrees if we just round to 3 sig figs. So our final velocity, velocity of the plane with respect to the air, so our airspeed, is going to be our magnitude, which we calculated here, 278 kilometers per hour at 1.81 degrees. Now, what direction is this? Well, if this is west, we are going to the south of west. So we are going to go 1.81 degrees south of west.